FastMCP 2 implements distributed tracing through OpenTelemetry's instrumentation API, enabling automatic span generation for tool executions and resource operations without requiring application-level modifications. The framework's provider pattern delegates span creation to the active TracerProvider, ensuring zero overhead when no SDK is configured and allowing seamless integration with any OTLP-compatible backend. We'll examine how the SDK initialization sequence establishes this tracing pipeline, beginning with the TracerProvider, configuration, and BatchSpanProcessor setup that will automatically capture FastMCP's component interactions. The code demonstrates how importing FastMCP after this configuration enables immediate trace export to the specified endpoint, with the framework handling all span lifecycle management internally. From OpenTelemetry, import trace. From OpenTelemetry, SDK, trace import TracerProvider. From OpenTelemetry, SDK, trace, export import BatchSpanProcessor. From OpenTelemetry, exporter, OTLP Proto, gRPC, trace exporter import OTLP span exporter. Hash configure the SDK with OTLP exporter. Provider equals TracerProvider. Processor equals BatchSpanProcessor OTLP span exporter endpoint equals http://localhost 4317. Provider add span processor processor. Trace set TracerProvider provider. Hash now import and use FastMCP traces will be exported automatically. From FastMCP, import FastMCP. MCP equals FastMCP my server. At MCP, tool. Def greeting, SDR. Return hello name. This code demonstrates programmatic OpenTelemetry configuration for FastMCP, establishing distributed tracing before server initialization. The pattern uses a BatchSpanProcessor with an OTLP exporter to collect and export telemetry data to a local collector endpoint at http://localhost 4317. This approach gives developers explicit control over the tracing pipeline, which is essential when you need custom sampling, multiple exporters, or specific resource attributes. The configuration follows a deliberate sequence, first creating a TracerProvider, then attaching a span processor that batches traces before export, and finally setting this provider as the global tracer before importing FastMCP. This order is critical because FastMCP's native instrumentation hooks into the OpenTelemetry API during import, meaning the tracer must be available at that moment. The BatchSpanProcessor is particularly suitable for production as it reduces network overhead by sending traces in batches rather than individually. This programmatic setup contrasts with the environment-based configuration shown earlier in the series, offering more flexibility at the cost of additional code. You choose this approach when you need to dynamically configure tracing based on runtime conditions, integrate with custom metrics, or when your deployment environment doesn't support environment variable injection. The trade-off is that this requires maintaining the tracing configuration in your codebase rather than infrastructure as code. Let's break it down. From OpenTelemetry, import trace. Imports the OpenTelemetry trace module for distributed tracing capabilities. From OpenTelemetry, SDK, trace import TracerProvider. Imports the TracerProvider class from OpenTelemetry's SDK trace module, which provides the foundation for creating and managing tracer instances in distributed tracing systems. From OpenTelemetry, SDK, trace, export import BatchSpanProcessor. Imports the BatchSpanProcessor class from OpenTelemetry's trace export module, which is used for batching and exporting telemetry spans in distributed tracing systems. From OpenTelemetry, exporter, OTLP Proto, gRPC,
Trace exporter import OpenTelemetry exporter.
Imports the OpenTelemetry exporter class from OpenTelemetry's OTLP gRPC trace exporter module, which enables exporting trace data to OpenTelemetry collectors using the gRPC protocol.
Provider equals TracerProvider.
Creates a TracerProvider instance for OpenTelemetry instrumentation, which will serve as the entry point for generating and managing traces in the application. This provider is responsible for creating tracers that can be used to instrument code for distributed tracing.
Processor equals BatchSpanProcessor OpenTelemetry exporter endpoint equals http://localhost 4317.
Creates a BatchSpanProcessor instance configured with an OpenTelemetry exporter that sends telemetry data to the OpenTelemetry collector endpoint at http://localhost 4317. The processor will batch span data before exporting it to the specified endpoint.
Provider add span processor processor.
Registers a span processor with the provider for OpenTelemetry tracing instrumentation. The processor parameter specifies which span processor to add, enabling the provider to export telemetry data according to the processor's configuration. This line directly configures the tracing pipeline without requiring additional setup.
Trace set TracerProvider provider.
Sets the global tracer provider to the specified provider object configuring OpenTelemetry to use this provider for all subsequent tracing operations in the application. This line establishes the tracing infrastructure that will be used to generate and collect telemetry data for distributed tracing.
#now import and use FastMCP traces will be exported automatically. From FastMCP, import FastMCP.
Imports the FastMCP class from the FastMCP module, which initializes a FastMCP server instance with automatic OpenTelemetry tracing enabled for observability.
MCP equals FastMCP myserver.
Creates a FastMCP server instance with the identifier myserver. That will be used in MCP protocol handshakes for client identification. The string parameter serves solely as a server label visible during protocol interactions, without affecting functional behavior or configuration.
At MCP tool. Def greeting SDR.
Defines a FastMCP tool function named greet that takes a string parameter name and returns a string. That MCP tool decorator registers this function as an MCP tool, automatically using the function name as the tool name and generating input-output schemas from the type annotations.
Return hello name.
Returns a formatted string that embeds the value of the name variable into the greeting hello name. This is a basic F-string interpolation that creates a personalized welcome message by inserting the current value of name into the string at runtime. The key takeaway here is how FastMCP2 achieves zero intrusion distributed tracing through OpenTelemetry's provider pattern. By configuring the tracing pipeline before importing FastMCP, you establish a global tracer that the framework automatically hooks into during initialization. The sequence matters. First, create the TracerProvider, then attach the BatchSpanProcessor with OTLP exporter, and finally set it as the global tracer. This order ensures FastMCP's instrumentation finds the tracer immediately upon import, enabling automatic span generation for all tool executions and resource operations. The BatchSpanProcessor is particularly noteworthy here as it optimizes network overhead by batching traces before export, making it production ready. This programmatic approach contrasts with environment-based configuration, offering more flexibility at the cost of maintaining tracing setup in your codebase. The trade-off becomes clear. You gain explicit control over sampling, multiple exporters, and resource attributes, but lose the simplicity of infrastructure as code configuration. Ultimately, this pattern demonstrates FastMCP's commitment to observability without sacrificing developer experience. The tracing infrastructure becomes invisible once configured, while still providing full visibility into your server's behavior through any OTLP-compatible backend.
The server whispers tool names to the decorator, but only strangers hear them clearly.